Okay, year 12. So in this video, I'm just going to go through all three different parts of this exam question. So part one here is kind of like a standalone part, and then part two splits into A and B, which are linked. Part B is quite tricky, part A is quite nice, and then part one should hopefully be quite straightforward. So without further ado then, part one. So solve in the range minus 180 to 180, tan x minus 40 equals 1.5. So because we've got here the negative 40 but this minus 40 is happening to our x, we need to make sure our range here is adjusted in the same way. So I'm going to subtract 40 from my range. So my range is now going to actually be minus 220 to 140. That's the range I'm looking at for now. So then after that, we are going to do inverse tan of 1.5. And so when I do that on my calculator, I get this, I get 56.3 degrees. Okay? And that's fine because it's within that range. We just need to find all the values of tan which are within that range. So at this point, you need to sketch out your tan graph. Okay? So your tan graph starts here, and then it has an asymptote. And the asymptote is at 90. So let's just mark on 90 there. So this is what it's going to look like. And it goes up like that. And it has an asymptote here. At x equals 90. And then it starts again down here. And it goes up to 180. And then it has another asymptote at 270. So this is 180 and this is 0. And then if we continue that same sort of pattern backwards, this would be minus 180 here. So then the rest of it looks like that, but better. And then here is going to look something like this. Okay, so then in terms of the value we've got a value of 56.3. Well, this here is 90, so 56.3 would be about here. Okay, so within that range then, my other equivalent value is going to be about here. Now, personally, the way I would spot this is, so from here to here is 56.3 degrees. So from here to here will be like 56.3 degrees along. So I would do minus 180 plus 56.3. Which is minus 123.7. Any other values? So we're only looking in the range minus 220 to 140. So that should be it for our range. And to get our actual values, we simply need to add 40 to both of these. So when we add 40 to both of these, and we're adding 40 because this is x minus 40. So to find x, we add 40. We get when we add 40, we get 96.3 degrees. And then we get minus 123 plus 40 is minus 83.7 degrees. And those would be the values of x within that range. Okay, so year 12, part 2 of this question, and it's a new part of the question, so it's a new part. So show the equation sine theta tan theta equals 3 cos theta plus 2 can be written in this form. Okay, so things to think about when you're given this type of question is how do this and this look similar? How do they look different? So first thing I spot, well, this is a tan theta in, this doesn't have a tan theta in, therefore we're going to do a substitution for tan theta. Now, tan theta can be written as sine theta over cos theta. So I'm just going to rewrite that first equation like this. Now I'm going to do this in quite a few steps. It would have been quicker just to immediately write that as sine theta cos theta equals 3 cos theta plus 2. So all I've done is I've replaced tan theta with sine theta over cos theta and then simplified. Okay, so that's looking a bit better. After that, well, I've not got any fractions, so how can I undo this fraction? I can multiply both sides by cos theta. So when we multiply by cos theta, we get sine squared theta equals 3 cos squared theta plus 2 cos theta. Okay, so this is getting a little bit closer now because I've got a cos squared theta, I've got 2 cos theta, so this is looking good. This, though, is the problem. So we're going to want to replace this now. So other identity that we want to know, in addition to sine theta over cos theta equals tan theta, is sine squared theta plus cos squared theta equals 1. Therefore, sine squared theta equals 1 minus cos squared theta. So I can rewrite this as 1 minus cos squared theta equals 3 cos squared theta plus 2 cos theta. And after that, it's simply a kind of a case of just adding some things to both sides. So if we add cos squared theta to both sides and minus 1 from both sides, we get 4 cos squared theta plus 2 cos theta minus 1, which is what we were aiming to get to. So I'm just going to write as required to show that I've got the thing that we were trying to show. Okay? Okay, year 12. And then for part B of this question, so like the final part, we have got hence solve. Now, if it says hence, that means use your previous answer. So I've just written the rearrangement from part A up here to save you having to like click back. But this was our rearrangement from part A. So now, instead of solving this here, I'm going to solve this rearranged version because they're identical to each other. So I'm going to solve 4 cos squared theta plus 2 cos theta minus 1 equals 0. So to do that, this is basically a quadratic in disguise because I could write this as 4x squared plus 2x minus 1 equals 0, where x equals cos theta. Okay, so I've just made that substitution. So I've got 4x squared plus 2x minus 1 equals 0. Now, normally I would recommend that you try and factorise this quadratic to solve, but actually this quadratic doesn't factorise. So at this point, we're going to solve this equation here. So you can solve it, use the quadratic formula. And actually the question wants us to show each stage of our working. So I will use the quadratic formula. I know your calculators will do that, which is helpful, but blah, 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 blah. So using the quadratic formula, we would get minus b, so minus 2 plus minus b squared, so 2 squared minus 4 times 4 times minus 1 all over 2 times 4. Putting that into my calculator now then is going to get minus 2 plus 4 times minus 1 all over 8 gives me this 0.309, and then the other solution is this minus 0.809. So, bearing in mind we made our substitution earlier, these are our values for x is. So either x equals, so 0.309 equals cos theta. So to find theta, which is what we're trying to find theta, we're going to do cos minus 1, 0.309. Well, I put that into my calculator. I get 72 degrees, almost exactly. So that's quite handy. So 72 degrees. Before we get on to solving this version, we need to sketch out our cos graph and find any other values. So our cos graph, it's in the range 0 to 360, so nice and straightforward. So just getting everything in our heights clear. This is the 0.90. So 72 will be about here. So the equivalent value, like the other value, will be about here. Now this point is 180, this point is 270, this point is 360. Personally, what I would do, I know that here to here is 72, so therefore I know that here to here is 72. So I would do 360, take away 72, 360 minus 72 is 288 degrees. Let's do the same sort of thing over here. So we're going to do cos minus 1, minus 0.809. So when I put that in, we get this. I get 144 degrees. And again, let's just think about what that looks like. So 144 degrees. Well, if this is 90, this is 180. So let's say 144 is going to be about here. Then there'll also be this value here. So to find this, what this value is, I would do 360, take away 144, which is 216 degrees. And then finally, just to kind of like conclude my work and make it super clear to an examiner, I would rewrite out all my answers probably in ascending order. So I'd get 72, 144, 216, and 280 degrees. Okay, and that's the final part of that question.